IP T101 Basic Theory. As shown in the figure below, decimal numbers 10, 12, 28, and 42 are represented using 6 squares that are black or white. A white square indicates 0, and a black square indicates a different positive value that is determined depending on the position of the square. First of all, let's look at decimal numbers. So decimal numbers are numbers which are represented using numbers between 0 to 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are the numbers we use every day. So they would be represented like 10, 12, 28, and 42, just like shown here. Okay, and next we're going to have a look at the numbers which are represented with the black and white squares. So in this case, numbers are indicated differently. So 10 can be represented like this. So we have some white squares and we have some black squares. If we have a look at this sentence here, a white square indicates 0. So a white square indicates 0, and a black square indicates a different positive value that is determined depending on the position of the square. So it looks like these black squares are the keys to determine the numbers. And these numbers are called binary numbers. So we have decimal numbers and then we have binary numbers. Binary numbers are used in programming, and since we cannot use so many numbers from 0 to 9, binary numbers are represented using only 0 and 1. So how do we know which one is 0 and which one's 1? Well, it says here a white square indicates 0. So white square means 0. Okay, and then the black square indicates a different positive value depending on where it is, and these are the ones. And depending on where these ones are, the number would differ. So let's have a look at how these squares work and how binary numbers can be determined. The question is, when the sum total of the values of the 6 squares shows a decimal number, which of the following is the numeric value that is represented by this binary number? A, 32, B, 48, C, 18, and D, 22. To answer the question, there is a very simple way of understanding the binary numbers and how they can be converted into decimal numbers. However, I want to talk about how to solve the question using the binary numbers given in the earlier slide. So considering white squares as zeros and black squares as ones, we can perform binary addition and subtraction on these numbers. To add or subtract binary numbers, the digits are arranged in the same way as decimal numbers and calculated from the last digit. So basically, binary numbers can be calculated in the same way as we do with decimal numbers. So let's perform the operations 28 take away 12 and 42 take away 10. So first of all, 28 minus 12. So if the white squares are zeros and black squares are ones, 28 can be written with 0 and 1s like this. So 0, 1, 1, 1, 0, 0. Same with 12. 12 can be written like this. So the calculation with these binary numbers is the same as what we do with decimal numbers. So 0 take away 0, and 1 take away 1, 1 take away 0, and so on. And we are left with this binary number 010000. So this indicates 16. Let's have a look at 42 take away 10. So we do exactly the same, and we're left with 100000, which indicates 32. Now, the reason why we did this calculation is because we need to have the set of 6 squares that was asked in the question that we need to determine using these outcomes of operations we just did. So let's do a recap of what was given in the question. So the binary numbers given in the question was 110000. So we're going to perform the last operation to determine what this means. Finally, we're going to do addition of 16 and 32. So 32 plus 16 is 48, and if we express the numbers with ones and zeros, we have 110000 as the binary number expressing 48. And as for the boxes, we have this. And this was given in a question, so the answer is B, 48. So this was how to determine the answer using the binary numbers given in the earlier slide. So now I want to talk about how to solve the question, how to solve this question by just looking at the binary numbers and how they work. First of all, I would like to talk about decimal numbers. Decimal numbers and the difference between decimal numbers and binary numbers. So decimal numbers are expressed with numbers between 0 and 9. So all the numbers we know. For example, if we have number 48, how do we tell this is 48? Well, let's have a look at this digit where 8 is. So this digit has the value of 10 to the power of 0. In other words, this is 1. So this 8 is 8 times 1, which is 8. How about this 4? Well, this digit has the value of 10 to the power of 1. So we know that this 4 is 4 times 10, which is 40. So we know that this 4 and 8 written like this is 40 plus 8, which is 48. How about a binary number? So let's talk about binary numbers. Binary numbers are expressed with 0 and 1. And we're going to take 48 as an example again. And we're going to look at each digit. So this digit on the very right, this has a value of 2 to the power of 0. So in binary numbers, bases are not 10, they are 2. So 2 to the power of 0 is 1. And as it goes up the digit, the value also goes up. So this has the value of 2 to the power of 1. This has 2 to the power of 2, and so on. And it works in the same way as the decimal numbers, but it just has different values. So, as I said, binary numbers are written in zeros and ones, and we learned that white boxes indicate 0 and black boxes are ones. So these are what we want to look at. So for 48, black boxes are on the digits of 2 to the power of 4 and 2 to the power of 5. So 2 to the power of 4 is 16 and 2 to the power of 5 is 32. Just in case you're wondering, all the other digits have these values. But here we're going to look at 32 and 16 because that's where the black boxes are. So this is why we can read this 32 plus 16, which is 48. If we look at 16, we have the black box on the digit of 16, and for 32, we have the black box on the value of 32. So this way, you can instantly tell a binary number and what decimal number it expresses.